Okay, we're going to learn about Pythagoras' theorem, or the theorem of Pythagoras. A theorem is just a mathematical rule that has been shown to be correct. And Pythagoras was a Greek mathematician who lived, he was born about 570 BC, died about 500 BC, so we're talking over 2,500 years ago. He didn't discover this particular rule, but he worked out or realised in actual fact it was applicable in all situations concerning one particular shape, and that's a right angled triangle. And so what we're going to have a look at before we look at the actual rule is what people kind of knew roughly about these right angled triangles. And that is, this was the very first triangle people realised. A right angled triangle could have sides 3, 4 and 5. And what Pythagoras realised was that if you take the side that's 3 units long and you draw a square from that, it gives you 9 boxes, 3 by 3, 9 boxes. If you draw a square off of the 4 unit side, you end up with a square 16 units long. And if you were to draw a square off the 5 unit side, that's the longest side, then you would end up with 25 squares, or 25 little boxes, because 5 times 5 is 25. And what people realised even before Pythagoras' time, that a 3, 4, 5 triangle would have a right angle in it. But what Pythagoras realised was a connection was that the numbers of those two squares, 9 and 16, give 25, which was a pretty interesting connection. Does it work all the time? Well, just to kind of clarify that means that 3 squared, 3 times 3, plus 4 squared, 4 times 4, gives you 5 squared, 5 times 5. So let's look at another right angle triangle. This time it's got sides 5, 12 and 13. So we'll draw a square off of the 5 side, and that gives us 25 boxes. A 12 by 12 square would give us 144 little squares, and a 13 by 13 square off of the long side would have 169 boxes. And sure enough, 25 add 144 is 169. In other words, 5 squared plus 12 squared is 13 squared. Okay, so one last one, just to check that we're not just making these things up. Here's another right angle triangle. 7, 24, and the long side is 25. The long side's always opposite the right angle, as we'll see in a moment. So let's just check that connection. 7 units on that one side. If I draw it out, 7 times 7 is 49. And on the bottom side, 24 times 24 is 576. And on the sloping side, 25 times 25 is 625. And sure enough, 49 plus 576 does give you 625. In other words, 7 squared plus 24 squared is equal to 25 squared. So in other words, this is, whether you believe it or not, it always works that the two shortest sides of a right angled triangle, if you were to work out the squares of each of those numbers and add them together, would give you the exact square of the long side. So Pythagoras kind of saw that connection, and he wrote down, he didn't have algebra at the time, but he wrote a word connection. And it uses, that connection that he wrote uses a Greek word called the hypotenuse. And the hypotenuse is simply the name for the long side. The Greek means kind of the longest legs of the triangle. So the hypotenuse is always the side opposite the right angle. In other words, it's the side that doesn't help to make the right angle. And that's really important to know. And what Pythagoras said was that in any right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. And that's really a word formula for what we just discovered. The square of the long side is the same number as what you get when you add the squares of the other two sides. Okay, so how does that help us solve a problem? Well, let's have a look at this one here. It's a right angled triangle. We know the two small sides are 6 and 8 units. It could be centimetres or metres, but I haven't put that in. And we want to calculate the length of the hypotenuse, which I've called A. So according to Pythagoras' theorem, A squared, the square of the hypotenuse, is equal to the sum of the squares of the other two sides. Sum is just a mathematical name for adding. Hope that you remember that. So here we've got a squared equals 8 squared plus 6 squared. It doesn't matter in this case if you put the 8 and the 6 first or second. As you can see, we're just adding them together. So we can simplify that equation by saying a squared is 64 plus 36. And sometimes you need a calculator to work them out, and sometimes you can hopefully just work them out in your head. Add the two numbers together, we get a squared equals 100. So we need to undo the squared term. The side is not 100 units long. We need to take the square root of both sides, and that gives us a equals the square root of 100, which again you might know, or you might have to use your calculator. We know here that 10 times 10 is 100, so a is 10. 10 units long. That's how we use Pythagoras' theorem. Okay, let's try out another one. Here we've got right angle triangle. It's 7 units and 10 units on its shorter sides. We're trying to find the hypotenuse A. So if we construct Pythagoras' theorem, it tells us that a squared is going to be equal to 7 squared plus 10 squared. We can go ahead and work out 7 squared is 49, 10 squared is 100, and then we can add those two together and work out that a squared is 149. The next step is we have to take the square root of both sides, which leaves us with a is equal to the square root of 149. That's not an exact answer anymore, so we have to take our calculator and we can round the answer to maybe 1 decimal place. So a here would be 12.2 units long. And it is important, if you're trying to calculate the hypotenuse, that your answer, of course, should be bigger than the other two numbers of this lengths of the sides in your triangle. It should be the largest number. Okay, so that's how we work it out. So I've got some triangles here on the screen, and what I'm going to do is just going to put them up, and you can have a go. If you pause the movie, you can have a go at a few of them, and I'll put the answers up when you unfreeze it. Okay, here's the answers that you should have got to these. And you'll notice that these are all whole number answers. In other words, in these triangles, all the lengths of the sides are whole numbers, and that's a really special case. It's not common at all. These numbers are called Pythagorean triples, but it's much more common for us to involve decimals in our answer. So what I've got another set of questions, and this time you're going to have to round your answer to 1 decimal place in each case. So you want to have a go at some of these. Pause it, and I'll put the answers up in a couple of seconds. Okay, so here's the answers you should have got. So if you're happy with using Pythagoras' theorem, you can go on and do some of the other exercises that I'm setting. If you've got any questions, please let me know.